These solutions are absolutely great for small and to mid-sized app, in my opinion. The more you scale, the more developers you have, the more things get complex. Maybe you want to look for something a bit more complex. So if you are at Facebook or Google, maybe you use Buck or Bazel. They are all very powerful and flexible systems. And with that, it also comes a high degree of customization. But the thing that we're going to focus more on today is the workers part, right? And here, I guess we can cluster the thing in two sections. So on-premise and cloud-based. Hi, everyone. Thank you so much for being here. And thank you so much for the organizer to organize such an amazing conference. This is actually the second time for me as Swift Heroes. I was here in 2020 talking about modularization and things. So a little bit about myself, just before we start. So I'm Italian, obviously. I spent the past 9 years at Just Eat Takeaway, doing all sorts of things around iOS, modularizing a big code base for global growth, working a lot on CI and CD, working a lot on CLI tools, building an internal developer toolchain, infrastructure in general. And of course, I've developed this little bit of a passion for DevOps and platform engineering, and I'm going to talk about that today. If you don't know the company, Just Eat Takeaway is a food delivery business. We're present in 20 countries, serving 700,000 restaurants, and of course, also in Italy. So what this talk is going to be about? So we're going to try to implement a continuous integration infrastructure in-house. We're going to use some interesting, cool technology. We're going to do it so that we can scale easily. We're also going to do it for achieving good performance, for fun, of course, and to learn new things, right? So a quick show of hands. Who of you has implemented some sort of continuous integration in-house? A few. That's good to see. So a few months ago, I wrote this article. And I think it was very well received by the community, but the feedback that I got was that it is very complicated to do this stuff, so difficult. So I'm going to try to keep it as simple as possible so that the more junior of you who haven't touched this area much will be able to follow, really. And the more senior of you will get hopefully, some insights so that they can reuse this stuff maybe at work. So the agenda is going to be following. We're going to do a bit of a recap to see what a continuous integration and continuous delivery system is, really. We're going to go through the existing CI/CD solutions available in the market. We're going to focus on one in particular, which is going to be based on AWS EC2 plus GitHub Actions. We're going to use DevOps tools to implement this setup, and then we're going to go through some final considerations. So what is this CI/CD thing? Well, I'm not going to give you the Oxford definition of it, assuming it exists. My definition is that it's a system that executes tasks on your code to allow integration and deployment of software. That's very boring, right? Continuously, if you're lucky. And we're going to get back to that in a second. But let's make a distinction between continuous integration and continuous delivery. So when we talk about continuous integration, really is about making sure that the changes proposed in a pull request, for example, are safe to be merged into the main branch. So this is where the continuous integration system will run the test, will run the validations, will run SwiftLint. Possibly it will generate some artifacts that we're going to post to some other system. And then we have the continuous delivery part, which is about deploying software so that it can be used internally or publicly. And this is where we use maybe Fastlane or things like that to build and archive and upload our app to our distribution channels. So if we try to visualize this in a continuous integration and delivery system, we have our developers who commit code to a source control platform, GitHub, for example. And then when a pull request is raised, we inform the system, well, the platform informs the server of the continuous integration, continuous delivery system that something has happened. So in that case, at that moment, the server will have some knowledge about the pipelines, and the pipelines, we can think of them as a sequence of jobs, a sequence of tasks to execute. And based on that, the server will dispatch jobs to the various workers that are separate machines and will run your fastlane lanes or your script. So the workers then, in the case of a continuous integration jobs will do their stuff, will run the unit test, the UI test, validations, and things like that, as we discussed, possibly generating also some artifacts that we're going to push to S3 or Artifactory, like screenshots or logs. And in the case of delivery, we're going to push our apps to maybe Firebase with app distributions or a App Store. And in the previous slide, I was saying if you're lucky, it's also continuously doing this thing, because in our case, on iOS, when we submit to Apple, it's not really continuous, right? So we cannot really ship to production multiple times per day. We have Apple that reviews the app for us, and so we might wait some time. But then, when the workers complete their job, so the different jobs, the workflows, we have multiple terms to describe the similar things. They will inform back the server, maybe via feedback service, that they're done, they've completed the job, and this is when in your pull request, you're going to see the status check, usually. And the developers are going to know if the things went fine or not. So having a system, a CI/CD system that works well is absolutely fundamental for DevOps methodology, so that we can code, build, test, release, and deploy our software in a continuous way. So now that we've done this introduction, let's go through some existing solutions that we have in the market. So compared to using the same diagram from before, I think it's beneficial to make a bit of a distinction between server and workers, right? It's very important here. So some solutions out there just pay a price for having the whole thing. So you have the server or build the system and the workers, right? Others only give you the server. Others only give you the workers, because in the iOS mobile space, apparently it's very complicated to have workers, right, on Apple platform. But anyway, at the end of the day, you really need the whole thing to have a system. An important thing to note here is that the workers need to be Apple hardware, right? So here we usually use Mac Minis or Mac Pros or things like that, while the server doesn't have to be on Apple. So usually it's a Linux machine. So if we go through some of the examples, some companies that provide server plus workers, here you have, Virtualization, Circle CI, and they're really beautiful products, ready to be used out of the box with minimal customization. They usually provide also some other services connected to that, maybe the dependency caching, etc. One thing to note is that the workers are virtualized, and with that we're going to discuss a bit later. It brings lower performance in the system, really. And it might take some time for some of these services to provide the new version of Xcode. I'm still thinking that GitHub took almost 1 month to provide the new version of 15, as Paul knows, to provide a new version of Xcode 15.3. While others, like CodeMagic, just publicized the other day that for the Xcode 15.4 beta, they had it ready in like no time, which is great. So there's a bit of a racing in this. Maybe to mention that Xcode Cloud is a special snowflake here, because if you use Xcode Cloud, you only have the option to use the server from Xcode, from Apple, and the workers. You cannot opt out. But if you use GitHub or anything else, you can use the build system from them and attach your own workers, right? These solutions are absolutely great for small and to mid-sized app, in my opinion. The more you scale, the more developers you have, the more things get complex. maybe you want to look for something a bit more complex. So if you are at Facebook or Google, maybe you use Bach or Bazel. Maybe you've been exposed to the one that must not be named there. So, when you talk about burnout at work, maybe you have a problem with your manager, your colleagues. Maybe you have a problem with Jenkins sometimes. Anyway, they are all very powerful and flexible systems. So, and with that, it also comes a high degree of customization. But the thing that we're going to focus more on today is the workers part, right? And here, I guess we can cluster the thing in two sections. So on-premise and cloud-based. On-premise is this, right? It's a very ugly picture. It is painful to maintain. You have your Mac minis in your server room. You have to take care of the connectivity, the power supply. There is really no simple way to replicate environments. You have to update software manually. Maybe you can do something with Ansible, if you know the tool, so that you can have the same environment updated remotely on the machines, but it's quite tricky, I would say. So if we move to the cloud, there are solutions that are more managed, right? And I'm not endorsing Mac Stadium. I think they're great. Just saying, not endorsing. I use it as an example here because they are probably the most famous, right? They have a massive data center in Atlanta with just tons of Mac minis, tons of Mac Pros. And once you have that much hardware, you can provide all sorts of services. So pretty much you can rent those Mac minis in the cloud, install your software, and go with that. Or you can use Orca, which is absolutely amazing as a technology, in my opinion. It stands for orchestration with Kubernetes on Apple. And that's their secret sauce, really. So Kubernetes is an orchestration solution to orchestrate Docker containers. So what they really have done is they have Dockerized macOS, and they orchestrate with Kubernetes for their clients. But what we're focusing on today is EC2. So EC2 is one of the services from AWS. AWS is probably the biggest cloud provider out there, and is the only one that provides Apple hardware, sorry. So they provide anything from Intel Mac minis to M1 and up to M2 Pro. So the EC2 service is the cloud computing solution that they have. So 99% of the times, your infrastructure team uses EC2 on Linux machines. And what happens there is that on the very powerful machines that AWS provide, we only get a single virtual slice of the thing based on the needs that you have, right? So with just the CPU that you want, with the block storage that you want. But in our case here, we are really not virtualizing. We are getting the Mac Mini, right? So from their rack, if we go on AWS, as we're going to do shortly, we're going to rent a Mac Mini for a specific period of time. So it is ours for 24 hours for. So I think we can start. So our solution is going to be based on GitHub Actions, but there's not much there to say because we probably are all expert in this, in crafting workflows in GitHub Actions, the pipelines, etc. But we're going to focus more on the workers that we're going to use on EC2, and we're going to connect them to GitHub Actions. And before starting, actually, a bit of a note on ClickOps versus IAC. So in ClickOps, you point and click in the UI to do what you want to achieve, right? It is error-prone, but it is absolutely intuitive. With infrastructure as code, you do things in code. The exact same things that you achieved in the UI, you want to write them in code, right? So that they are predictable, they are versioned in Git, and with that, it comes, the code review process and the fact that the changes are auditable, right? So we're going to start with ClickOps first so that you see how it works in the AWS console. Ready? Yes, that's what I wanted to hear. So we're going to go to AWS. We're going to log in. we're going to go to the EC2 dashboard. And the first thing is to go to the dedicated host section because we need to rent a Mac Mini, okay? So we're going to allocate a Mac Mini. And here, there is just a couple of things that we want to select. And Mac2 Metal pretty much stands for M1 Apple Silicon. Okay, it's just a way they categorize the type of instances. So once we have it, okay, we have it there, we have it available, our Mac Mini is ours for 24 hours. And then we move to the instances section, and we're gonna launch an instance on top of it. So here, in this view, there will be tons of settings, but there are just a few things that we are going to focusing on in order to have our instance. And okay, yes, we're going to give it a name. Then the next thing, very important to set correctly, is the AMI. AMI stands for Amazon Machine Image. You can think of it as the sequence of bytes on the disk, kinda, right? So the software that you want installed on this. We're going to select macOS Ventura because we live in the past. And then we're going to move on to this section here, which is going to be about, we're going to match the instance type of the underlying dedicated host, again, Mac2 Metal. And then we're going to move to this section here. Sorry, I'll try again. To the key pair section, because we need to generate a key pair that we're going to use later as an SSH so that we can sign in over SSH, log in over SSH, and so that we can install our software. And the next section, very important, is also to set up a security group. Security groups are pretty much the virtual firewalls for EC2. And we have absolutely to enable to open port 22 because we're going to use the private key to SSH into the machine and sign to install our software. And in terms of outbound traffic, maybe we don't define anything, so the machine can talk to the rest of the internet. Not very secure, but we are simplifying things today. And then maybe as a last step, we can configure some storage, 256 gigabytes. We're going to review, and we're going to launch our instance that will be available and running in no time. So now that we have our private key, we can SSH over it. And once we are in, we can also screen share using VNC. And once you are in, you can log in the UI, you can install Xcode. And it's time to elevate our machine to the role of actual workers or runner in our CI/CD system. So we need to connect it to GitHub Actions, right? And the way we can do it is by pasting the code from the settings of your repository. So if you go in your repo, you go in the runners section, you're going to select the operating system and the architecture. GitHub gives you some code. We're not going to go through it, but it's pretty much to download the app and to configure the app. And once you do that, you have your runner connected so that you can start using it. Great. But what if you want to redo this process all over again, right? Maybe something that we can do is creating an image, or an image with a template would be even better, so that the next time that you run an instance, instead of starting from Ventura, provided by Amazon, you're going to start from your image that already has the software installed, right? So that's a little bit of an improvement. And you're going to find the AMI in the list here once you create it. Now, we want to do all of this in code, right? Let me introduce to you a couple of my friends. So first one is Packer. Packer is a tool from HashiCorp. And HashiCorp is a company that provides tools for DevOps stuff. So your DevOps team at work is really the tools that HashiCorp provides are pretty much the bread and butter of DevOps, right? They provide from solution for secrets manager to Packer and others. So Packer is used to create the image. Creating the image was the last step in ClickOps because we set up everything and then we exported the image. Here we want to start with the image. We want to have the image with all the software, and then we're going to deploy it. And we're going to deploy it with Terraform, which is another very interesting tool, is for the infrastructure as code thing. All right? So we're going to see some code now. It's not Swift, but shouldn't be too scary. So this is the Packer definition of the AMI. We're going to define some variables. In this case, we can just define with the macOS version, the Xcode version that we want to install, and the password of the user on the machine that we want to set. And then here there is some code that is pretty much telling Packer to go on AWS, create the instance for us on a specific dedicated host. It's going to search for the AMI, the Ventura AMI, and it does that by interpolating the macOS version variable that we have defined before. It's going to find the AMI, it's going to run an instance, and once the instance is up, we're going to run our scripts, right? So for simplicity, the first one maybe is just to set the password of the main user that is present on the machine. Then it's going to be the next interesting step of installing Xcode that we can do programmatically like that or something like that. And then all the code that you've seen before to actually downloading the software and connecting the instance, which is the one that we've seen before from the settings of the repository. So now that we have that very simple definition in Packer, we can run Packer, which is a CLI tool. Now we are familiar with CLI tools. And we're going to call Packer build. We're going to pass the variables. We're going to pass the configuration file. Packer is going to run. It's going to print some logs. At the end of it, we're going to have our AMI available in AWS EC2. Now that we have the AMI, we want to deploy it, and we're going to use Terraform for this, right? So similar code here. We start with the definition of the variables, and the important one here, the only one that we're going to use, is the fleet size, which is the one that makes things scalable later, right? So the number of instances that we want in our cluster. Then we move on to the secrets part, right? So we have generated the key pair, the SSH key in the console. And if you do it in the console, in the previous section when we were doing ClickOps, it downloads the private key locally. But when you do it with Packer, you don't get this, right? So you need to store the SSH key somewhere. So there is some extra code down there that pretty much saves the SSH key in Secrets Manager, which is another service from AWS. And then we're going to define the security groups, right? It's going to be a single one with 2 rules. As we said before, we really need to open port 22 so that Packer can connect over SSH and install the software for us. And we do it like that. And then we're going to define the AMI. So the AMI is what we actually created with Packer in the previous section. So it's not something that Terraform has to create for us. And that's why we use the data keyword here. So we're basically telling Terraform, don't create the AMI. This is not something that you need to have control over. I'm giving you the AMI information, but make a reference to it because we're going to use the AMI in the definition of the AWS instance, which is the real thing on the Mac Mini, right? So in here, yes, we make a reference to the AMI. We make a reference to the security group that we just created, to the fact that the instance type is Mac2Metal, to the key pair, of course, and crucially, we're going to define the count to be the variable of the value of fleet size, which is the thing that makes it scalable. So all of that is the definition of the infrastructure, a very simple one. We can run it with Terraform, which again is a CLI tool. We're going to do Terraform apply, we pass the variable, and once it completes, we have everything created in AWS like we did when we did ClickOps, right? So the code that you've seen is declarative, right? So if you run this line multiple times, Terraform keeps the state. So if you run it multiple times, it's not going to create multiple instances. It's a bit like Swift UI. So the system controls the state. If you don't change the state, it's not going to create a new view. The view is the same. Here, the infrastructure is the same if you run fleet size equals 1 over and over again. But if you change it, for instance, to 5, and you run Terraform, Terraform is going to say, oh, okay, you want 5, I had 1, I'm going to migrate the state to 5, therefore I'm going to create 4 extra instances, right? Which is very interesting. And Terraform, yeah, again, is really good at maintaining the state. And then we can call Terraform destroy if we want to destroy the whole thing, so we don't leave any trace of any entry security group SSH key in AWS. In all of these, though, we haven't discussed the dedicated host, the underlying Mac OS, Mac Minis, right? So we could do that in Terraform, absolutely. I'll show you a different way of achieving this because, you know, the Mac Minis are really the resource that costs a lot, right? So maybe if you want to have more precise control over it, you want to do it over manually, using the CLI that AWS provides. So you can allocate hosts, you just pass a bunch of parameters and define the quantity. And then you can also release the host when you don't need it anymore. Now, there's more to this, right? That was just a very simple summary, I would say. So the machines connect to GitHub Actions, right? But in order to connect to GitHub Actions, you need a join token. And in order to get a join token, you need to make an API call with a personal access token or an enterprise token. And you don't want to save this secret in the AMI itself because, you know, security reasons. So you want to save it in Secrets Manager, as we did for the SSH key. And if you save it there, you also need to come up with a way for the instance to get the value. So you start defining an instance role or permissions in IAM, which stands for Identity and Access Management, which is another service, very important service, within AWS. And once you have that, you probably want to pass the ID of this thing to the instance when you're running it, so that when it runs, it's going to get the secret and connect to GitHub Actions. And if you want to do this, you will end up using EC2 macOS Init, which is a tool provided by AWS to handle startup operations on macOS. So the moment that you start dealing with the cloud, AWS and these kind of providers, they're all a bit interconnected. So you start with EC2 and you get some knowledge about Secrets Manager or maybe other services like DynamoDB and IAM, etc. So it can get complicated. A bit of a recap. So we started with a dedicated host in ClickOps. We ran an EC2 instance on top of it. We SSH'd in, we installed Xcode, we installed our GitHub Actions runner, and then we exported AMI. And then we moved to infrastructure as code. So we started with the AMI, we generated that with this code installed. Then we deployed it using Terraform on one instance. That was based on a Mac Mini that we allocated with AWS CLI. And because we used that fleet size variable, we could scale our infrastructure to whatever number we want. And now that we have multiple Mac Minis that are called self-hosted runners in GitHub Actions, in GitHub, you can update your workflows so that they can run on our specific infrastructure. But now we can do a step further on this, right? If you remember at the beginning, I was talking about continuous delivery and continuous integration. Here, we are deploying instances. So it is deploying some sort of infrastructure. So it's a delivery of something, right? How about we use the continuous and delivery infrastructure that we have, GitHub Actions, the server, to actually create some nice dashboard for the operations that we've seen, right? So the operations that we want to automate really are the creation of the AMI, the deployment and the decommission of the entire infrastructure, and the allocation and the release of the dedicated host. So for the first one, you can create a nice workflow that will call Packer, and you can map the variables of Packer to the variables of the inputs in the workflows. So the moment that the new Xcode is going to come out, Xcode 16, that is going to fix all the bugs that Apple have introduced, you can just come here. If your setup is properly done, you run the workflow, maybe also with the Ruby version, because why not? And you're going to have an AMI ready in no time, right? That we're going to then deploy with Terraform that we put behind a workflow and GitHub Actions here. You pass the AMI identifier, you're going to tell how many instances you want, and boom, you have your infrastructure created. And you can also have workflows for allocating and releasing the host. We're getting towards the end, right? So some final considerations. If we want to take it a little bit further, so we could consider automating the scaling. And AWS is very good with auto-scaling groups, so that if you get too much traffic on your system, you can scale automatically. Here is a bit more complicated because it's not that if you get too much traffic, you want to scale, right? It's not that really. You would want to consider some service in the middle that decides how many pull requests or jobs are coming through so that you can scale according to certain rules, but not maybe based on the CPU usage. Or you can consider some smart scaling, where, for instance, you reduce the number of instances of your cluster during the weekend, because technically nobody works during the weekend, so there's no point of having a number of Mac minis up. Maybe just one would be fine. Or you can do CloudWatch monitoring. So if your instance starts having 80% of disk being used, that's a bit too much. Things are going to explode shortly, so you want to be notified. So some monitoring there and alerting. Or maybe you can go crazy and do infrastructure as code for all sorts of things. If you are not on GitHub Actions and are on Jenkins again, you might want to have your server instance of Jenkins defined in AAC, so that, again, you get all the benefits that we discussed instead of installing and updating the plugins of Jenkins manually. Or another idea would be to have the GitHub repositories defined in code. That's something that not many people do, but if some new person joins your team, what you usually do, you go in the settings, add the person, make sure that the groups are fine, or maybe you're going to make sure that the branch protection rules of your repositories are in place. If you define all of that in code, that's just great, especially if you have a number of repositories. And again, I would like to say optimize your pipelines. So that's really important, because if you have a number of Mac minis that are somehow expensive to have, and your pipelines take like 2 hours to run the UI test, okay, maybe spend some time in optimizing that first. We haven't talked much about virtualization, so I would like to say just a few things. Apple have introduced the virtualization framework a few years ago. And so you can have virtual machines. Within the same Mac OS, you can have 2 different Mac OS versions, right, with related software. Yeah, there's a hard limit on 2 virtual machines per host. There are solutions created on top of this framework, CLI tools, you guessed it, such as Tart, and also there is Anka on AWS. Of course, with this comes, as I said before, lower performance, at least in my experience. And I would like to say, don't be fooled by virtualization, because in one of our teams, the team in Canada, at Just Eat Takeaway, they moved from a solution that was on virtual machines, and every PR was taking like 34 minutes, and they got used to that, right? Because you get used to some slowness over time, and you don't question it much. Then they migrated to this infrastructure that is on metal, bare metal, and they cut down time to 9 minutes. So yeah, if you consider one machine with 5 developers, 10 pull requests on average per day, just as an example, you see the virtualization actually is not helping you. It's going to take more time. And if you are on bare metal, 1 hour and 30 minutes maybe, and you have a faster feedback loop. So the impact is real in my experience. So run your numbers. And if you have a big app with tons of UI tests, virtualization is just not going to work. I tried multiple approaches, but it's just not enough. If we want to talk about cost a little bit, we could compare for the rest of the afternoon. No, we're not going to do that. Prices across the solutions and do all sorts of spreadsheets, but it gets very complicated. There are many variables. What I would like to say is that the more you scale, the more you save, especially on AWS, where there are savings plans. The prices of these machines also change per region. So if you are in North Virginia, the M1 Apple Silicon machine is the cheapest one I could find. And again, if you do smart scaling so that during the weekend you reduce the number of instances, you can save quite a bit. So if we want to do some back of the envelope calculations, I hope I got them right. But if you get, for example, 5 instances per month on Orca, you're going to spend quite a bit. Yeah, it's a fair price. But if you try to do things in-house with, again, smart scaling, then you can reduce the prices significantly, right? And if you are on Mac Mini, well, that's a very different story, because on AWS, maybe those expenses are OPEX, so operational expenditure, which is something that companies prefer. If they buy assets, like the Mac Minis, then you enter the amortized cost, the depreciation of the assets, etc. But that's probably the cheapest one. But it comes, of course, with a lot of maintenance paying. So to conclude, a question is buy versus build. Well, it really depends. I'm not presenting you this solution that's going to solve all of your problems. It's one of many ways to set up a CI/CD system. It really depends on the company size, the team size, the code base size, how many developers you have, how many pull requests and CD jobs you expect per hour. So you have to really run the numbers. But it also depends if there is a DevOps or platform engineering team in your company that maybe have some existing knowledge of this stuff and can support you to extend the infrastructure on Mac hardware. Or if anybody in your team from the mobile Swift team would like to skill up, learning more of this stuff is definitely beneficial, right? So again, no solution fits all. And again, things evolve over time. I would like to conclude with an example from Just Eat Takeaway. Like 9 years, we were on TeamCity, right? And then we migrated to Bitrise, which is an amazing product, right? Very simple to use. But the team was like 3 people. So we didn't have enough resources nor time to create anything more than that. So we had to rely on an external provider. And then we migrated to Jenkins with Mac Minis in-house. The photo that you have seen earlier about those Mac Minis, I took it from our server room. It's awful. And then the pandemic hit, and the Mac Minis were in the server room. So each of us took one Mac Mini at home because there was nobody in the office. So if there was a power cut, what do, right? You are left without CI. And then in 2020, AWS announced the macOS instances, and we migrated to the cloud and created pretty much an infrastructure defined as the one that you've seen today. So that's all I have for you today. Thank you very much.
That was good.